Terminating circuits in an electrical panel requires careful planning and execution. Several observations and suggestions can help improve the process. Planning the placement of circuits is crucial. Before beginning any terminations, carefully consider where each circuit will be located within the panel. Take into account the location of the service conductors, which are the main wires bringing power into the panel, and the overall size of the panel itself. Circuits should be arranged in a logical and organized manner. One common approach is to group circuits based on their function, such as lighting circuits, receptacle circuits, or appliance circuits. Another option is to group them by the room or area they serve, like all the circuits for the kitchen or the bedrooms. Avoid crossing circuits unnecessarily. Crossing wires can make it difficult to trace circuits later on and can create a cluttered appearance. Also, avoid making sharp bends in the conductors, as this can damage the wires and make them more difficult to work with. Regarding terminations, it is important to ensure that all terminations are secure and conform to the manufacturer's specifications. This means using the correct tools and techniques to make the connections. Use the correct torque for the terminal screws. The manufacturer of the circuit breaker or other component will specify the proper torque value, which is the amount of force that should be applied when tightening the screw. Using a torque wrench is the best way to ensure that the correct torque is achieved. Over-tightening the screws can damage the terminals, while under-tightening can result in a loose connection. Use wire nuts that are sized for the number and size of conductors being joined. The wire nut should be large enough to completely cover the exposed wires, and it should be rated for the voltage and amperage of the circuit. Wrap the wire nuts tightly and in a clockwise direction. This helps to ensure a secure connection and prevents the wire nut from loosening over time. Maintaining good panel organization is essential for safety and ease of maintenance. Keep the panel organized by using cable ties or wire management clips to bundle the wires together. This helps to keep the panel neat and tidy and makes it easier to trace circuits. Label all circuits clearly using indelible markers or circuit labels. The label should indicate the circuit's function, such as kitchen lights or living room receptacles. Make sure there is sufficient space between circuits to allow for easy access and maintenance. Cramped conditions can make it difficult to work on the panel safely. In addition to these suggestions, there are other considerations to keep in mind. Using a wire sizing tool can help ensure that the conductors are sized correctly for the circuit load. This is important for safety and to prevent the wires from overheating. Inspect all wiring for damage or deterioration. Look for signs of cracking, fraying, or corrosion. Replace any damaged wiring immediately. After all terminations have been made, test all circuits for proper operation. This can be done using a multimeter or other testing device. It is also a good idea to have a qualified electrician inspect the work before energizing the panel. This will help to ensure that the work has been done correctly and that the panel is safe to operate. Here are some useful rules of thumb to follow when terminating a panel. Firstly, use the smallest possible wire size that is appropriate for the circuit load. Smaller wires are easier to work with and take up less space in the panel. Secondly, keep the number of terminations in a single panel to a minimum. The more terminations there are, the more cluttered the panel will be. Thirdly, use the panel with sufficient space to accommodate the number of circuits needed to terminate. It is always better to have too much space than not enough. Fourthly, plan the placement of circuits before beginning to terminate them. This will help to ensure that the panel is organized and easy to maintain. Fifthly, make sure that all terminations are secure and conform to the manufacturer's specifications. This is essential for safety. Sixthly, keep the panel organized and well maintained. This will make it easier to troubleshoot problems and keep the panel operating safely. Here are some additional tips that can be helpful. Firstly, use different colored wire nuts for different circuit voltages. For example, blue wire nuts can be used for 120 volt circuits, while red wire nuts can be used for 240 volt circuits. This makes it easier to identify the different circuits in the panel. Secondly, use heat shrink tubing over wire nuts to protect them from vibration and moisture. Heat shrink tubing is a type of plastic tubing that shrinks when heated. It provides a protective barrier against the elements and helps to prevent the wire nuts from loosening. Thirdly, consider using a ground bar instead of terminating grounding conductors directly to the panel. A ground bar is a metal bar that is connected to the grounding system. It provides a convenient place to terminate all of the grounding conductors in the panel. Fourthly, use a torque wrench to ensure that terminal screws are tightened to the correct torque. A torque wrench is a type of wrench that measures the amount of force being applied. Using a torque wrench ensures that the terminal screws are tightened to the correct specification, which is important for safety and reliability. Fifthly, keep a record of all the circuits terminated in a panel, including the wire size, circuit breaker size, and circuit function. This information can be helpful for troubleshooting problems and for future maintenance. Grounding electrode conductor, or GEC, connections are also important to consider. The grounding electrode conductor connects the electrical system to the earth, providing a path for fault current to flow back to the source. This helps to protect against electrical shock and fire hazards. There are several ways to terminate the GEC depending on the type of grounding electrode being used. If the grounding electrode is a metal water pipe, the GEC can be connected to the pipe using a grounding clamp. The clamp should be installed on the street side of the water meter, or on a metallic water pipe as near as possible to the point of entrance to the building. If the grounding electrode is a ground rod, the GEC can be connected to the rod using a grounding clamp or a listed connector. The clamp or connector should be installed at least 6 inches below grade. If the grounding electrode is a concrete encased electrode, the GEC can be connected to the reinforcing steel in the concrete using a listed connector. The connector should be installed before the concrete is poured. The size of the GEC is determined by the size of the service entrance conductors. National Electrical Code, or NEC, Table 250.66 provides guidance on selecting the appropriate size GEC. It is important to ensure that the GEC is properly sized to provide adequate grounding protection. All connections should be made in accordance with the NEC and local codes. Proper grounding is essential for electrical safety. Always follow the NEC and local codes when installing or modifying an electrical system. Consider these additional points regarding wire management. Efficient wire management is key to a well-organized and safe electrical panel. Proper wire management not only makes the panel look neater but also simplifies troubleshooting and future modifications. Firstly, planning is essential. Before starting any wiring, plan the layout of the wires within the panel. Consider the entry points of the cables and the location of the circuit breakers and other components. This will help to minimize wire crossings and keep the panel organized. Secondly, bundling and securing wires using cable ties or wire management clips to bundle and secure wires. This prevents wires from becoming tangled and makes it easier to trace circuits. Use different colors of cable ties to identify different types of circuits, such as lighting, receptacles, or dedicated appliance circuits. Thirdly, neatly routing wires. Route wires along the sides or back of the panel to keep the center clear. This provides easy access to the circuit breakers and other components. Avoid running wires directly across the front of the panel. Fourthly, labeling wires is crucial for easy identification. Use wire labels or a permanent marker to label each wire with its corresponding circuit number or function. This will save time and effort when troubleshooting or making future modifications. Fifthly, maintaining adequate spacing between wires. Avoid overcrowding wires within the panel. Maintain adequate spacing between wires to allow for proper ventilation and prevent overheating. Follow the NEC guidelines for wire filling conduit and enclosures. Sixthly, proper grounding is also important for wire management. Ensure that all grounding wires are properly connected to the grounding busbar. Use screen-insulated wires for grounding and bond all metal enclosures to the grounding system. Consider using a wire duct or wire trough to route wires within the panel. Wire ducts provide a neat and organized way to run wires and protect them from damage. Choose a wire duct that is appropriately sized for the number and size of wires being routed. Also, make sure all panel knockouts are properly sized and used. Use the correct size knockout for the cable or conduit being installed. This prevents damage to the wires and ensures a secure connection. Use appropriate connectors for connecting cables and conduits to the panel. Use cable clamps or connectors to secure cables to the panel and prevent them from being pulled out. Use conduit connectors to connect conduits to the panel and ensure a watertight seal. Always follow the NEC and local codes when installing or modifying an electrical panel. These codes provide important safety guidelines and requirements for electrical work. A properly wired and well-managed electrical panel is essential for the safe and reliable operation of an electrical system. By following these tips and guidelines, it can be ensured that the electrical panel is safe, organized, and easy to maintain. Regular inspections are crucial. Regularly inspect the electrical panel for any signs of damage, such as loose wires, corrosion, or overheating. Address any issues promptly to prevent electrical hazards. Finally, consider professional assistance. If uncomfortable working on the electrical panel or have any questions, consult with a qualified electrician. Electrical work can be dangerous and should only be performed by someone with the necessary skills and knowledge. In summary, careful planning, secure terminations, organized wiring, and regular maintenance are essential for a safe and efficient electrical panel. Always follow the NEC and local codes and consult with a qualified electrician if needed. Some notes on using torque screwdrivers or torque wrenches. Firstly, know the correct torque specification. The equipment manufacturer lists the torque specification for each terminal on the equipment. The torque specification will be listed in inch-pounds or Newton meters. It is important to use the correct torque specification because too little torque will result in a loose connection and too much torque will damage the equipment. Secondly, use the correct tool. Use a torque screwdriver or torque wrench that is properly calibrated and sized for the application. A torque screwdriver is used for smaller terminals and a torque wrench is used for larger terminals. Thirdly, set the torque. Set the torque screwdriver or torque wrench to the correct torque specification. Fourthly, apply the torque slowly and evenly. Apply the torque slowly and evenly until the torque screwdriver or torque wrench clicks or reaches the set torque. Do not over-tighten the terminal. Fifthly, check the torque. After tightening the terminal, check the torque with a torque screwdriver or torque wrench to ensure that it is within the specified range. Finally, keep a record of the torque. Keep a record of the torque applied to each terminal. This will help to ensure that the terminals are properly tightened in the future. Using a torque screwdriver or torque wrench is an important part of ensuring that electrical connections are properly made. By following these tips, the risk of electrical problems can be reduced. The underwriter's laboratories or UL listing is also a consideration. UL listing is a safety certification provided by Underwriters Laboratories, a globally recognized safety organization. UL-listed electrical panels have been tested and evaluated to meet specific safety standards. The UL mark on an electrical panel indicates that it has been found to be free from reasonably foreseeable risks of fire, electric shock, and other hazards. UL-listed electrical panels are required by many building codes and are often preferred by insurance companies. Choosing a UL-listed electrical panel provides assurance that it meets established safety standards and is suitable for its intended use. Key benefits of using UL-listed electrical panels are firstly, safety assurance, as UL-listed panels have been tested and evaluated to meet specific safety standards, reducing the risk of electrical hazards. Secondly, code compliance, since many building codes require the use of UL-listed electrical panels. Thirdly, insurance requirements, because insurance companies may require or prefer the use of UL-listed electrical panels. Fourthly, peace of mind, given that using UL-listed electrical panels provides assurance that the electrical system is safe and reliable. When selecting an electrical panel, look for the UL mark to ensure that it meets established safety standards. Using UL-listed electrical panels is an important step in ensuring the safety of the electrical system. Also, consider arc fault circuit interrupters, or FSIs. FSIs are circuit breakers that are designed to protect against fires caused by arc faults. An arc fault is a dangerous electrical condition that can occur when damaged or deteriorated wiring creates an unintended electrical discharge. ASIs are designed to detect arc faults and quickly shut off the power to the circuit, preventing a fire from starting. ASIs are required by the NEC in many areas of the home, including bedrooms, living rooms, and dining rooms. They are also recommended for use in other areas where arc faults are likely to occur, such as kitchens and laundry rooms. Key benefits of using ASIs include firstly, fire prevention, as ASIs can prevent fires caused by arc faults, protecting lives and property. Secondly, increased safety by reducing the risk of electrical shock and other electrical hazards. Thirdly, code compliance, because the NEC requires the use of ASIs in many areas of the home. Fourthly, peace of mind, as installing ASIs provides assurance that the electrical system is protected against arc faults. When installing or replacing circuit breakers, consider using ASIs to provide enhanced fire protection. ASIs are an important safety device that can help to prevent electrical fires. Regarding ground fault circuit interrupters, or GFCIs, these are another critical safety device designed to protect against electrical shock. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are designed to detect ground faults and quickly shut off the power to the circuit, preventing serious injury or death. GFCIs are required by the NEC in areas where water is present, such as bathrooms, kitchens, and outdoor receptacles. They are also recommended for use in other areas where ground faults are likely to occur, such as laundry rooms and garages. Key benefits of using GFCIs include firstly, shock prevention, because GFCIs can prevent electrical shock by quickly shutting off the power to the circuit. Secondly, increased safety by reducing the risk of electrical hazard. Thirdly, code compliance, because the NEC requires the use of GFCIs in areas where water is present. Fourthly, peace of mind, in that installing GFCIs provides assurance that the electrical system is protected against ground faults. When installing or replacing receptacles, consider using GFCIs to provide enhanced shock protection. GFCIs are an important safety device that can help to prevent electrical injuries and fatalities. Here are some thoughts on surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, which are sudden increases in voltage that can damage or destroy sensitive electronics. Voltage surges can be caused by lightning strikes, power outages, or other electrical events. SPD work by diverting excess voltage away from the protected equipment and safely to ground. There are two main types of SPD. Firstly, whole house SPD, which are installed at the electrical panel and protect all of the equipment in the home. Secondly, point of use SPD, which are plugged into individual outlets and protect specific devices. Key benefits of using SPD include firstly, equipment protection, because SPD can protect valuable electronic equipment from damage caused by voltage surges. Secondly, increased reliability, given that SPD can help to prevent equipment failure and downtime. Thirdly, cost savings, because SPD can save money by preventing costly repairs or replacements. Fourthly, peace of mind, as installing SPD provides assurance that the electrical system is protected against voltage surges. Consider installing SPD to protect electronic equipment from voltage surges. SPD are an important investment that can help to prolong the life of electronic devices and prevent costly damage.